monomials, binomials. A binomial, we'll actually divide by that at some point. That's like a two separate terms. Monomials is a single term. Looks something like this. Could be like this, single term, or like a 3x. This is actually technically a polynomial, but most of the time polynomials, they're working with like 3 or more terms, something like this. This would be like a polynomial, okay? So if we're dividing polynomials by monomials, you're taking something with 2 or more terms and dividing it by a single term. And I think the best approach here, using our exponent principles and rules, the idea that if you're dividing letters with exponents, you're subtracting, so you have x squared over x minus 2x over x plus 1 over x. You can break down this division into 3 separate divisions here, and that makes things, again, look a little bit more organized. I have a 2 minus 1, the x minus, this is an x1 and x1, so actually your x's cancel out, minus 2. And since there is no way to simplify this fraction, it would just be left 1 over x. And that's what you're doing when you're dividing there. You can have a little bit more to it, where you're working with okay. Now it looks like a lot. Oh, this just increased so much. But if you, I mean, we just worked with. If you look at this separately, it's just basically 3 separate exponent rule problems that you're working with. I like this last piece of it because it's actually a term divided by itself, which is 1 here. But you're looking at the 12 over 3 as you would just a regular fraction to be 4 over 1. So this turns into a 4. I'll basically just look, where do I have more exponents? So I have my x's here, I have more on top. I'm going to leave that on top. Here I have y3 plus 15 divided by 3 is 5. These x's cancel out, I'm left with a y. And then this here and here is 1. If I had, let's say, for whatever reason, let's say I was dividing by 3xy3, and this was a 1 on top here, like this, then actually this would be plus 5 over y2. Let's say if I had more exponents on the bottom. Go ahead.
Can you repeat that one more time?
Yeah, so I'm just talking about a different case.
Mm-hmm.
Because in each of these, there was more exponents on top.
Right.
Well, actually, in this one was the same amount, so they canceled out. So if you see, we had more exponents on top, so it was just x1, y3, there was nothing on the bottom.
Mm-hmm.
So I showed you a case where, let's say, for whatever reason, you end up dividing, and you have more exponents on the bottom here. So you have 1 on the top, 3 on the bottom. Then after you're dividing this needs to stay. This needs to stay on the bottom here, yeah. This would be a proper way. I don't know if you'll see much of that. And then the other thing you want to look at too, let's say in one case you end up with like it was 3x y squared over 15 xy like this, where you see you have the 3 over the 15. This actually reduces to actually x's cancel out, y over 5, because 3 over 15 would reduce to 1/5. So actually the 5 would be on the bottom there if you were dividing like that. And then we have an example of that here. So this will reinforce what I just kind of spoke about, negative 3x See, right away we see that case of, okay, there's gonna be more exponents on the bottom than there is on the top. Negative divided by positive is going to be negative. The 3's cancel out. I have 2 more on top. 6 over 3 is 2. Actually, you know what? I'm going to make this just x. So you can see what happens there. I'm just going to make that just x. So here we have 2. But recognize there's more x's on the bottom. So it's actually 2 over x squared. Plus, this is like 1/3. These cancel out. This x can't, so basically you're left 1 over 3x to the third. Recognize what happened there. The division of the 1 kind of left this as a fraction, like a 1 over 3. X, you have 3 more on the bottom, so here's your final answer here. That should cover